Hello and welcome. This is now further maths. We're going to be visiting conic sections and in particular an ellipse. This is a 5-star problem. It's a recent question that I think it went into one of the FP3 papers. And what it's actually saying is an ellipse has a focus at 5 minus 3 and directrix with the equation y is 2x minus 7. If the eccentricity of this particular ellipse is root 5 over 10, find the coordinates of the point of intersection of the ellipse with a straight line with equation y is equal to minus 3. Where do we start with something like that? With something like that, probably, first of all, start by recording the given information down. So somewhere on the side, it's not a lot to actually remember, but very little went in when I actually read it. Maybe I'm a little bit tired at the moment. F for focus. Of course, an ellipse has 2 foci. That's one of them. And the directrix has equation y is 2x minus 7. If the eccentricity, that's also a given that the eccentricity little e is root 5 over 10. So that's the givens. Find intersection of ellipse with y is equal to minus 3. So that is basically what is the problem. And where do we start? Really start? I mean, at the moment I've just recorded the information purely because of the video. I don't have that piece of paper in front of me, or you rather don't have this piece of paper in front of yourselves. And we need to have some things down before we start. But where we really start with something like this is a picture so we can see what's going on. So this is the directrix. The directrix is 2x minus 7. And at right angles to the directrix, we got a point P with coordinates x, y. This is on the ellipse. It's a locus. The question now is the distance from the foci. The foci has a eccentricity less than 1, between 0 and 1. So that means this distance to the focus now, and the focus is 5, negative 3. This is actually, for a parabola is equal. For an ellipse, the ratio of PF, let's call this point PQ, is actually equal to the eccentricity, which is less than 1. So let's write these things down. From this picture, PF divided by PQ is equal to E. And this is in fact given. And in fact, it is less than 1. It's positive and it's less than 1, as we expected. Okay. The next thing from there is we need to have something about this Q. Well, this Q, if it lies on the line 2x minus 7, then its coordinates, I don't want to use x and 2x minus 7. I'm going to use a different letter, k. You can use t for a parameter. It's because I have more here, x and y, k and 2k minus 7. So for some k, we have there these coordinates. Okay, so let's bullet point that. And let's move to the next step. We got a perpendicular here. So that means the gradients basically are negative reciprocals of one another. So the first thing that I'm going to say is grad of PQ is got to be, since the line has gradient 2, the directrix, then this line will have gradient of -half. And from here, I can get an expression for the gradient, which of course is a mess. Difference of y, so I can say y minus 2k plus 7. I didn't put a bracket, I've done in my head obviously. And x minus k is equal to -half. 2y minus 4k plus 14 is equal to -x plus k. Pardon for my cough. I'm on my 4th or 5th video today. Normally I record on Saturdays loads of videos. I feel a little bit better after treatment on Fridays, and but it's still too much, and after a while I'm coughing and I'm doing all sorts of things. So 2y plus x plus 14 is equal to 5k, which I can write of course as 5k. Actually, I'm going to write it here. 5k, it's not a given, but it's a fact now. 5k is 2y plus x plus 14. So that's this line. I'll just write it back to front. So that's the next thing. Now we're going to start making use of this fact. The length of PF, I'm just looking at this bit here, is equal to E times the length of PQ. I'm leaving E as E because I don't want to be putting this certain thing straight away. And then I'm going to square it. So I'm going to say, look, PF, when I square it, because that's the length, it will square the square root, is equal to E squared PQ all squared. And from this line here, what is PF? PF is, of course, x minus 5 all squared plus y plus 3 all squared. It would have been square rooted, but of course I squared it, is equal to E squared. So E squared would be now 5 over 100, that's a 20th, 1/20th. And the PQ is, of course, difference in x. So x minus k all squared, x minus k all squared. Again, the square root would have gone from the square, and then it's y minus 2k plus 7 all squared. Very messy. Need loads of space. I'm choking at the moment. So where we're going to make space? First of all, let's lose the picture. Do we still need this picture? No, it's going to be, we're having one equation and we got another equation there, and there's a third equation, as you will see. The third equation is actually quite trivial. We're not going to just be keeping it to the end. So at the moment we used it. All of this we don't need. So let's take all of this off. I'm still leaving the last line there so I can manipulate. So somehow I want to lose this case from in there and in there. The problem with the case is I don't want to create that over 5, and the way I will do it, in order to go inside the this brackets which are squared, is to actually multiply the equation by 25. I've done that in simpler examples, and I showed loads of workings, but I will show a lot less now. This is a 5-star question, and I think we should be able to see what I'm doing. I'm timesing the equation by 25. That is all I'm doing. So I'm going to get 25 lots of x minus 5 all squared. That's the left-hand side of that. Plus 25 lots, as stupidly left at 1/20th. I'll do it on the next line. Now I'm not rubbing off. And then we got, of course, the 1/20th. I will leave it as it is. I don't want to put the 25 there and get 5/4 because I really want that 25. Now, when the 25 goes inside the bracket which is squared, it needs to go 5 there and 5 there, and that's the 5 squared and the 5 squared there. So this is the whole point of doing this. So I'm going to have a 5x minus a 5k all squared, plus the same thing, of course, since we go to the other bracket, distribute. So we're going to have a 5y. Now it's going to be a minus 10k, because there was already a minus 2 there. And the 5 will go plus 35 there, all squared, close bracket. And lastly, let's do a bit of a tidy in all of this. So we're going to have a 500, that's by times the 20 across, x minus 5 all squared, plus another 500, y plus 3 all squared, equal, and we'll lose all these square brackets. And at the same time, let's start putting this k in. So minus 5k. 5k is down here, but it's a minus, so it's going to reverse all these signs. Minus 2y minus x minus 14, all squared, plus a 5x. Because I am very tired at the moment, I'm trying to write it here and love it off. Times by minus 2 is equal to minus 4y minus 2x minus 28. So that's my minus 10k. So minus 4y minus 2x minus 28. And of course, that was just the k. Very easy to forget the 35 there, all squared. All right. Tidy still. So at the moment, how we're going to get anywhere with two unknowns and one equation? Let's write it and we'll have a little think about this. So we got there a 5x minus x is 4x minus 2y minus 14, all squared is a factor of 2, which we can square it and go 4 on the other side. It might be useful. Plus 3x 3x there, something is not quite right in there. What am I doing? I'm copying wrong from this line to this line. This will be a 5y there. I do apologize. You can see how easy to make mistakes. This is entirely my fault now. So that's going to be a y. Let's get rid of this first of all. That's the copy from there, and that's the minus 10k. Let me just check the 10 minus 10k. Minus 2, minus 4y, minus 2x, minus 28, minus 4, minus 4x. What is going on? Can somebody help me with all of this, because I'm losing the plot now. Sorry, this is now, let me just underline it. That is my 10k. No, it's correct, y. And of course I got there still a minus 2x, and then 28 plus 7. Gosh, my brain is just disintegrating. I think I have about 3 molecules working at the moment. God, shameful. All right, let's think about what this is. This is the ellipse. An ellipse is, of course, of the form x minus, actually no, let's not use minus, say minus alpha all squared over a squared plus the general form, obviously, for an ellipse, which is shifted and is equal to 1. So when you tidy all of this up, this is going to be, of course, a transformed ellipse, because of course the directrix is not like a vertical or a horizontal line. So this is the equation of the ellipse. We're not interested, if you look at what the question is actually asking, we're not interested to find the equation of the ellipse. An ellipse has this bits of information given, and it says find the intersection of the ellipse with a line y is equal to minus 3. So all we need is to say, you know what, y is minus 3. All I want is now the x coordinates, so it's something minus 3 and something minus 3. I'm expecting, of course, well, maybe it's a tangent, I don't know, but I doubt it. That is a tangent. It will cross into place, even if it's tilted, something like that. The line y is equal to minus 3, something like this. I'm expecting to get 2 coordinates with, of course, minus 3 as your y coordinate. So in this mess, we're going to put y is equal to minus 3. A lot of things will simplify. So this equation will become 500 x minus 5 all squared, putting minus 3 in there, goodbye my friend, is equal to y is equal to minus 3. So this will become 4x, what are we putting, minus 3. So that's going to be 6 minus 14 is going to be a minus 8 all squared. Let me just double check. It's 6 minus 14 is minus 8. And this one, we're putting y is equal to minus 3. So that is a minus 2x. Minus 3 plus 7 is plus 4 all squared. Okay. These two bits are the same thing, really. So what I'm going to do next, x minus 5 all squared, factorize a 4 out of this and then square it. So it's going to be 16. I factorize the 4. And from here, I'm going to factorize a negative 2 and square it. So it's going to be plus 4 when it comes out of the bracket. And of course, we're going to have x minus 2 all squared. 500 x minus 5 all squared is equal to 20 x minus 2 all squared. And then x minus 5 all squared, x minus 2 all squared is equal to, is it 500 divided by 20 or the other way around? The x minus 2 needs to be times by 20. So that's this way, and this one is the 500. And there's still more algebra going with this, but we're almost at the end now. The hard bit was this manipulation when we put the 25 in and tidy this particular expression. I think even with a calculator, this would have been an absolute nightmare. It's not an easy question to handle. Okay, put this squared. So what do we have now is, of course, x minus 5 over x minus 2. Let's put it all squared. That's going to be 2 over 50, which is 1 over 25, which is good news, of course, because this will give us now nice numbers. X minus 5 over x minus 2 is 1/5, or of course, x minus 5 over x minus 2 is equal to minus 1/5, because of course we got to have 2 pair of coordinates. And from there, all right, 5x minus 25 is equal to x minus 2, or 4x is equal to 23. X is 23 over 4. That's the first x coordinate. X minus 5x minus 25 is equal to minus x plus 2. And then we have 6x on the left is equal to 27 on the right. And x is, of course, 27 over 6, which is the same as 9 over 2. And the problem has now finished. The required coordinates. Do you want to substitute to get the y coordinate? I wonder. I think my 3 molecules in my brain can just about cope with that. Of course, the y coordinate has to be minus 3. And I have answers for this as well. You can see the answers at the bottom. 23/4 with minus 3 and 9 over 2 minus 3. Okay, that was a tough question on ellipses. I'm not quite sure if this is on normal further maths or is the kind of like the further maths, but I hope it made sense. And you coped all right. You follow what I've done in there. A lot of difficult algebra and tedious perhaps at times. Okay, I'm signing out. I will see you real soon. And on that note, okay, and I hope you have broken up from school. It's July now. Okay, enjoy your summer. Bye for now.